Hello and welcome back to Molten Modular DIY. In the corner I'm going to make a little project, a little expansion as it is, towards the Turing Machine. Turing Machine is one of my favourite all-time Eurorack modules. It's a generator of randomness that is so elegant and beautiful that it can easily infect your entire rack with nice voltages, if there is such a thing, and the occasional gate, the occasional pulse. And actually that's a kind of a nice feature in that rather than getting a constant thump on every single note, you just get this occasional thump. But we can do more with that, apparently, so I'm told, and this is going to enable that by building what's called the BitBuddy. It's an expansion. It pulls out a whole bunch of either pulses or gates that you can use to do more in your system. Exactly what that means, well, I don't really know yet. That's why I'm going to build a thing, so I can find out. Now this kit comes from Axis Modular, supplied to me via Thonk. Thank you very much. Now, by the looks of it, it's not too intense, but what I have spotted is a little bit of surface mount. That's going to be fun. So while it's not particularly intense looking, it's going to present some challenges, which gives me a good opportunity just to flex my manual surface mount soldering skills. Oh, that's a very small thing. Okay, that's a blank. But in here somewhere is the real stuff. So come and have a look. Have a look at what we've got here. So this is the front panel, the BitBuddy from Axis. So ultimately we're looking at some ultimately we're looking at some LEDs and some jack sockets. That's it, really. That's pretty much it. This is the PCB. These are going to be our resistor surface mounts. Then there's a connector, some jack sockets, some LEDs. That's it. There's not a whole lot to it. So that's quite exciting. We have... So... What do we get in entirety? That's a cable. Is that a power cable? Why would we have a power cable? I think this is the cable for connecting it to the back of the Turing machine. That will become clear. So let's have a look at what we have. We have the panel and the PCB. We've got a bunch of things in here which look small and delicate. So a bunch of LEDs. These are flat-headed ones, and these crazy resistors. Let's hope they're all the same. And then in our little envelope, we have the ribbon cable connector and just a bunch of thonky kongs, a bunch of patch sockets, each with a screw on it. Super. So let's put those to one side for the moment, and I will turn on the soldering iron, get that charged up, make sure I've got all my bits and pieces like my safety specs at the ready, my magnifiers, because I'm going to need those without any doubt whatsoever. And let's have a look at what the manual has to offer. So here we are, BitBuddy. At the top here, I think I've just skipped through the entire build to get to how to use it. So here we go. Thanks for purchasing the BitBuddy. So it gives gates and pulses, suggests you have some things like this, we'll see, and that we agreed to do this at our own risk. Lovely. So, okay, there are two types of resistor. That's interesting. So this bunch here, there is writing on them. Gee whiz, I cannot read it. Nope. Okay, on the other group here, this does have 2.2 written on it, so 2.2K, I think. So that's going to be good. And these have a slightly different designator. So it doesn't tell me what that is. But side by side, they are definitely different. Cool. There are quantity, 10-pin connector. Okay, right. Just trying to understand. Which is that? Got that. Good. Thonk jacks, which are these. Yeah, it should be 9 of. 1, 2, 3, 4, 5, 6, 7, 8, 9. A bunch of LEDs. Should be 9 of. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9 of those. And a panel. Panel. Good. Right. Excellent. Oh, look. That's a really nice close-up. Do not connect to power rail. You know, it's worthwhile they write that on there, because I'm the sort of person who would, because this is the same cable as the power rail one. It is the same cable, and this is the same connector as a power cable connector. That's perhaps a slight flaw in the Turing machine's design. So it's suggesting that we need to do the 1K resistors. They're labelled 1001. Carefully peel them back. So, is that really what that says on there? Now there must be a way, right, that I can look at that a little bit closer. So (1,001). There you go. So I can look at it, you know, here's a tip. Look at it through your phone. You can they're getting a bit meta. There you go, 1001. You can see that, yeah. So even my magnifiers are not really helping at this point, but you know, get a phone and zoom in a little bit, and that can help. So, back to the manual. Carefully peel back the tape and remove. I recommend finding a decent sized bowl to place these in. They can ping, and then we just have to stick them on. So the 1K resistors are going to go R1 through to R9. R1, 2, 3, 4, 5, 6, 7, 8, 9, all the way along there. Whew, okay. I've just noticed something on here, which is rather nice. Look, it says, thanks to DivKid, Thonk, Molten Modular, and Melodies. How lovely is that? How lovely is that? So I use a technique, it says, where you add a small blob of solder to one pad, heat it, and then move the part into place using your tweezers. Yeah, I do exactly the same thing. So that's what we're going to do. So we're going to get a bit of solder, and we're just going to put a glob of solder. Here's the plan. Onto R1. So heat the pad. Add some solder onto there. Onto the pad, not onto the soldering iron, ideally. I'm going to do that all the way down. So for this, you need a pair of tweezers. Like so. Right, now this is going to start getting tricky. Now I have two pairs of tweezers. One of them is really good, and one of them is really not. And I can never remember which one is which. So I just kind of have to go with whatever it is I have in my hand. Now I thought I had both pairs, but now I do not. Oh dear. Oh look, there they are. Look. So which is the better pair? I think it's this lot. Anyway, so let's go back to our 1001s, which is this lot here. Now it suggests putting them into something so they don't fly away, because they really do. You can just take a breath and fly it away. In fact, that's why I haven't put my fan on just yet. I think I'm going to probably do this fanless, because the possibility of them blowing away is not something that I relish at all. Now, a nice young man called James has just gifted me a little tray for components. So heck, this is an opportunity to try to use this. Oh, look, see, one's already flown. I will drop them into here. And that will hopefully keep everything together. They are weeny. Look at them. They are tiny. Absolutely minute. So let's do that. Let's get myself in some kind of order. So the plan is with this, right, is that I'm going to grab one, present it, and then heat the solder. Got it? So I can put this in even closer potentially, because this is interesting, right? See that? Okay. So I'm going to grab hold of it again, try not to twang it. Just going to heat this pad that I put the solder on, and I'm going to push the fella into it and let go. Did you see that? Now in some ways I'm not sure I've got quite enough solder on there, but hey, it's on, and if it's on, you know, it's kind of on, isn't it? Take another one. Heat that up. Push it in. And it's there. And again. Now, would it matter if they were upside down? Probably not. In fact, we know they wouldn't. But it's good to be able to see what each of these resistors is, just in case you do completely screw it up. Oh! See, for some moment there I thought I was going to steady it, and that was unnecessary, and I ended up going up sideways. Can you see any of this? Probably not. Just bring this back up here. Alright, well they're on there. They're on there. I might do the next lot with a little bit more solder, I think, but heck, they're there. So, but that's only one side. I've now got to fill that in with the other side. Are you with me? Now I've got to do the same sort of thing and add solder to the other side, to the other leg, without breaking it, removing it, burning something. So you have to heat the pad and try to heat the end a little bit, present it with some solder in the hope that it will solder itself down without just going all over the end of your soldering iron. But in some ways this bit is a bit trickier than doing the other side. Oh no, oh my goodness, I've had a rupture. Let me just do this one down here. Not quite sure what I was doing there, but that did not go well. Right, so I've now got to somehow, we're better off taking that off, I think. So it wasn't really ever stuck on here, I don't think. So rather than fighting with this, I'm going to attempt to remove the solder and try it again. Okay, I have one of those left. Don't know why I have one left, but I do. I'm not going to worry about having one left. So now I've done those, we now have to do the 2201s, which is this bunch here. 2201s. I can read that actually, funnily enough. Is that going to focus? No, heck is it like. So same job, but these are going into the LR bits. So on here where it says LR up to 8. Exciting, isn't it? Exciting times. So let's put that one spare one out of the way so that does not feature, and let's see if I can extract these from here. Good. So let's put another blob of solder onto this pad. Trying to keep it on the pad, not just on the soldering iron. Just end up with the tiniest bit. Just seems to be how it goes. Right, so let's try to do the same with these. That's in. Heat it up. Push it in. See again, if I try to steady it, it always ends up going bad. Alright, better that time. Better that time. Actually, that might work slightly better. If I push it in and then just sort of hold it down as I remove the soldering iron. Yeah, that does look better because that leaves a better sort of trail of solder behind it, which I quite like. Like that. Ooh! Ah! I didn't let it cool. Better. Good. So that is all of those surface mounts. You see, it wasn't hard. It's fiddly, yeah, of course. But it's not hard. You don't need a flux pen and heat gun and all that sort of business. You could do it. I mean, I'm saying this now, of course, but I have no idea whether this works yet. It may all be for naught. But heck, whew, that's done. I mean, the manual just say put some flux on, and that's probably the thing that you should do in order to get the solder to flow that little bit better than I was getting. But, you know, it's just a whole other thing, isn't it? So now what do we have to do? The connector socket. Right, now anyway, back onto this thing here, which is the power connector. Follows the silk screen. Have a look. Okay, cool, that's fine. Does it say anything important? Oh, there's some nice pictures. Look at that. That's what you need. Great. So come back onto that. So what they're talking about is here. You've got these two things. You see this big gap you've got here. That needs to go with the big gap that's there. That's the only bit of information you need, really. Nothing else is particularly as useful as that. And you know that's got to be that way round, and then the cable goes in, and it goes in the right way round because it's got the bit that fits into that socket, into that slot. So that's the bit to get right. It also helpfully has red stripe written on it here. So when you put that in there, and then you look at your ribbon cable, this is going to have to go this way round in order to fit in the hole. And the red stripe is, of course, on this side, which is where it says it should be. Brilliant, even though this covers it up, which is a bit of a shame. But hey, if you weren't using a shroud like that, then and you're just using headers, then that writing underneath would be very, very useful. Right, so just got to solder that in. Could do with being supported on something, so it's not going to fall over. And then your best bet is always to do one leg and then go. I'm going to stick my air on now, so I'm not breathing any more of the fumes, and I'm not in danger of throwing away a surface mount component. So I'm just going to hold that steady while I release it to hope that it's as straight as possible. That looks great. That looks great. So solder the rest of that. Okay, there's a point here that I'd quite like to make, which is that I haven't done the other side of these surface mount ones, and that's an easy thing to forget about because you've pushed it in, you fished it in, you feel like you're finished, and you haven't. You've got a whole other side to do. So I've got a whole row of resistors here that are not actually soldered in. So let me do that. Shall I do that? That would be a good thing to do, I think. So all of these LR ones, I mean, rather perhaps than doing them in a row like I did, doing them all in one way, perhaps it's better to do them one at a time. So you do one in its entirety as opposed to just doing one end of it. That might be good, mightn't it? Now, of course, I've got a problem, a little bit of a problem here, because I don't want to find myself melting the shroud that I've put on. But hey, you've got to do what you've got to do, haven't you? This is getting well messy. Now with a bit of luck, that is somehow done. Good. What happens now? Once you're happy, carry on. Yeah, okay, stick the mono jacks in. All the jacks. All the jacks? All the jacks. So, next up, all the jacks. Do not solder. Just put them in. And then we'll do the LEDs. Looks like we're doing the soldering at the end. Alright. So in our little thing here, we take our patch socket. Now we're going to make sure this is on the right side. So it's not on the side with the shroud, it's on this side. You can see the lovely screen print that's showing us exactly where they go. So long twangy leg goes into the outside bit here, and then the other bit just kind of slides in beautifully. It just works. It's a beautiful thing. That just goes in like that. It feels good. Now I'm going to take off the nuts as I go, because I think those are going to be going on the other side of the front panel. So if yours came with nuts on, it's worth taking those off. Okie dokie. So now we're moving on to the LEDs. Long leg positive, and again, do not solder. As you can see, yeah, positive is printed on the board, and as far as your LEDs go, you have a long leg and a short leg. Long leg is positive. So all we're doing now is putting these in here. Long leg positive, long leg into the positive hole, and dangle it in. That's all that's required at this point. See, that's not going to want to go. Okay, that one's having a bit of time because I think I doubled some solder over the hole or something. I don't know. Let's just go with it. It's sticking out, but we don't really care. Long leg positive. Long leg positive. Oh, for heaven's sake. Alright, got it all in. Got it all in. Do not solder. Okay, so the plan is now to put this on. Now it's suggesting that you use some masking tape over the front in order to hold the LEDs on, which is a good idea, absolutely a good idea. I'm just going to pop this on here and ignore that advice for the moment. And what you need to do is put some of the screws back on, or all of the nuts back on rather, so it holds it on properly. So I don't think you need to take this off again. I think this is pretty much it. I think we're almost there, which is remarkable really. Just got a bit of soldering to do. Now there is a way up that these nuts go, which is to have the little slots sticking out, because you can potentially use a tool in order to either tighten them up or take them off. That would go into that little bit. So, right, yeah, so getting the LEDs in, what you want is have them nicely up, sticking in the holes. You want them sticking in the holes. Now, the type of LEDs that these are, I don't think I've seen this quite before, is that they just stick themselves straight through. Most LEDs I've worked with have little, I don't know, have little shoulders that butt up against it. I've never seen them just go steaming like that before. So in which case, some masking tape is probably going to be a good idea. Now, is that the sort of thing I have knocking about the place? I think I might have done at one time. Definitely seen some. What am I going to do about that? Oh look! Yeah. I do have some. Good, right. Some very unsticky stuff. So stick it across there. Yeah, and then your LEDs will just go up against it. And they may even stick a little bit. Oop. I've got a couple of rogue ones because of the solder that was already there. So I'm just going to smooth across the bottom of that to make sure that they're all nice and flush. Nice and flush. Good, got that? Yeah? Cool. Anything else we have to do? Solder. Yeah. Good. So we've got the patch sockets and the LEDs to do all the way across. trying not to unhinge the surface mount Watsits as we go. Oh, little bit of melting. How do we think that went? Pretty nice. Pretty nice. Yeah, pretty nice. I'm liking that. Liking that. Just going to check over the soldering to see whether I've missed anything vital. No, that looks alright. So I'm going to take off these longer legs. Clean it. Yeah, alright. Now connect it to your Turing machine. How exciting. So, yeah. That is it. That is it. It was a nice short build. Yeah, nothing to that particularly, was there? Turn my bits off. Turn your bits off. Right. Good. So there. Axis Modular BitBuddy. So this is going to have to go over there into my Turing machine. I should have got a silver faceplate. Oh well, that don't matter. So, I mean, it's not actually powered, so you're not going to get a smoke test off it. I'm not going to be plugging it into power. I'm just going to be connecting it to the music thing, and hopefully a little bit of current will flow through it to light the LEDs, and we'll start getting interesting things happen. Exactly what? I don't know. I'm quite fascinated to find out, to be honest. So I'm going to do that, but I go off and have some lunch first, I think, and then come back and do that. So there you go. That was a build. I hope that was helpful. Don't forget to solder both sides of those surface mount resistors, and don't be scared by them. They're easy. Long leg positive. That's really all you need for this entire build. So yeah, the rest of this is going to be looking at how it works. Nice one. Our Turing machine is here. Now on the back you've got a couple of ports, one for gates, one for pulses. I've suddenly had a thought, right? Suddenly had a thought. And that thought was that somewhere out there in the world I've got a pulses. I do. It's one of the first things I did that had surface mount on it. And I get the feeling that this is going to be very, very similar. I get the feeling this is going to be very similar to the BitBuddy. Possibly, I don't know. In fact, finding out what is different between them might be something that's useful. But I'm going to put this to one side for the moment and just focus on the BitBuddy. Now my choices on the back, as I say, are to connect to pulses or gates. My understanding is that they're different. I guess one is essentially triggers and the other one is going to hold on for a length of time. But again, I guess we're going to have to try it out and see. So what I need is the cable. I could try the cable that came with it just to be sure, just to make sure. But are these the same as power cables? Yeah, I mean it absolutely is the same. But for this goes in here and is going to connect to, what should I connect it to? Pulses. Now it shows you where the red line is there. I'm going to connect it to that, like so. No lights so far, but then I haven't given the Turing machine a clock. The one thing a Turing machine does not have is its own clock. Oh, upside down, this way around. So before I do anything else, let's give it a clock. Now sadly I have nothing happening on my BitBuddy. Very sadly. I would assume that something would happen. I don't need to patch it, do I? Yes. Do I? Do I actually? This I do not know. But that was interesting, wasn't it? If I plug this into there, it suddenly does a load of stuff. But it does it wherever I place it. What the heck? What the heck? So what does this mean? Am I plugged into there, right? This is pulses, right? So what would it mean if it's not getting like an earth connection? Is that the connection it's not getting? Let me try plugging it into pulses. Ah, it's got a different connection. Needs a proper fat cable. So from that regard, they most definitely are going to be different. So that's red down there. Let's plug that one into gates. Plug this one, red down there, to pulses. If I plug that in, that's running all the time. That should be the clock through. Now that would say to me, I think, that there's probably a connection which is not completely right. Okay, great. So what I'm going to do is I'm just going to pull the front panel off. I'm going to have a look at all the soldering and see whether we get to somewhere that's a bit more useful than where I am now. Right, okay, I'm back, having resoldered, or reflowed rather, poked around on the back of that, tested things, put multimeters on things, trying to work out what on earth is going on. When I looked a little bit closer at the demo video, I noticed that the one in the video was completely dead until it plugged into something. So essentially, until I patch it into something, you get no lights. You get no lights. Now, in a DIY build, I would strongly suggest that that should be in the manual in great big capital letters to say that when you plug it in, nothing will happen. Nothing will happen. You'll get no lights of any kind. Nothing. I think I'm slightly manic at this point. Because that is ridiculous. That is ridiculous. Oh my goodness. Well, I guess you're supposed to know how to use your Turing machine. I mean, the first thing to say would be you will get no lights because the clock isn't plugged in. You need to plug the clock in first. That's first and foremost. But then also say you'll get no lights if it's not patched to anything. So patch it first. Got it? Oh my lord. Right, so that's hilarious. That's hilarious. Well, it's not really funny because I've just wasted a whole load of time. So thanks for that, Axis. Your otherwise brilliant manual, which was, you know, superbly illustrated, showing me everything that I needed to know. And I bet it probably even says, and I've just completely missed it. No, it doesn't say anything about it. It doesn't say anything about it. Oh dear. This is why I'm here. I had this with the last build that I did on whatever. What was that? Oh yeah, the oscillator. How there's just these little bits that are missing from the build that you just little bits of obvious stuff. I mean, of course it's not going to light up with lights until you plug something into it. No, I mean, I don't get that. Why on earth would it plug in? Why on earth would it only light up when that happens? I don't know. Anyway, I've now plugged that into a kick drum, right? I'm going to lose my mind. Right, so let's plug another one randomly into a snare drum. And let's take these out into my little molten motion meter mixer over here. Going to take the out of the hi-hat just for extra fun, and then take all of that, put that in here, to see whether that's actually going to do anything. See, that's already interesting. But you can't hear it. So very excitedly, after all of that, I'm getting a bit of a drum pattern. I don't know how or why it's doing what it's doing, particularly. Maybe this is going to be my whole new drum kit. That's brilliant. Okay, if I turn it to the right, the Turing machine gets a little bit less excitable. It's really interesting. It's interesting. It is really fascinating. So this first one here reflects the pulse that's coming out on the Turing machine. I think that's clear enough. What the hell happens to the rest of them? I have no clue. But I guess what it's doing is following this line of lights here. You see that? This thing here. So these lights are reflecting each other. Yeah? That's what I think's going on. What do these lights mean? Nobody knows. Nobody knows what these lights mean, but they are nice and they have something to do with the notes that are about to come. So if I can turn that into a loop. So it's just going to do 4 now. 4 all the way across and then 4 again. Then it introduces a bit more randomness and that starts to break up. So how is that different from pulses, I wonder? And how different would it be if I'd used gates? Oh, I mean, these are questions we can only answer by giving it a go. I shouldn't have screwed all this back in quite so much, should I? But it's given it a lovely bit of jazz drumming, don't you think? So if I pull this out of here, plug it into gates instead. I don't think that's made any difference. I don't know that it's supposed to. So let me plug pulses in just to see how that compares. Right, I've learnt an awful lot about Turing Machine in the last half an hour or so, right? Which has been quite exciting, I have to say. And I can definitely tell you that when I first built the pulses many moons ago, I had no idea of the potential of what was coming out of here. But now, through interacting with this BitBuddy and trying to work the heck out, what on earth, what is going on? I've discovered all sorts of things, and with the help of Richard over at Access, that has been enormously helpful. So what is going on? Well, a number of things. And I mean, most of it is to do with how the Turing machine works, which is just bizarre. I think everyone has to agree. Bizarre but beautiful. And the BitBuddy is doing some interesting things in order to interpret that. Is it the same as the pulses? Yeah, pretty much. Pretty much. There are some differences. The pulses has these sort of logic outputs here, but only actually has 7 steps as opposed to 8 outputs on the BitBuddy. So they are similar companions. They're not really either or. They are slightly different angled things taking the same sort of information and running with it. So at the moment I have this. Has an enormous amount of jazz to it, I think. You know what I could probably do is introduce some swing. Do I know how to do that? No, is the answer. Oh my goodness. Anyway, I don't want to get confused by the PAMs, because that's something that the PAMs likes to do, is basically confuse us. So let's just take that off for the moment. So what is going on, you could ask? Well, I've captured a loop. I've turned this all the way across, so I've locked it, so it's now just repeating the same 6 steps over and over again. Now what I've got the BitBuddy attached to, I've got 4 of them attached to the molten motion meter over here, just flashing away, and that is actually mixing the outputs to give us the melody. What? So let me take the melody for the moment. So I've got everything going through this little quantizer here, this little central British quantizer. So if I take the output of the Turing machine, it's giving me that. That's great. I can use that. That's fantastic. But instead, I can take this series of triggers, because essentially it's a trigger or a gate. It's just an opening and closing. It's a massive leap to, I think, 10 volts. I don't know. It could be 5 volts. Who knows? But it's a massive leap on and off. And I can use those and scale those through my molten motion meter to create a different melody. So if I turn all those down for the minute, I'm taking these top 4 outputs, and they're all lighting up at different times, one behind the other, and that is going into the motion meter here, taking the output. Then as I turn each one up, can't quite see that from where you are. So that gives me the on-off, yeah? And I can go all the way up to the full range of what that gate is giving us out. So if I scale that back a bit, I can then mix in another one, which is slightly offset to it. And that starts to give me a melody. I can mix in another one. And another one, and I've generated an entirely different melody, but from gates, which I've never done before. That is fascinating. Totally fascinating. Meanwhile, I've got my bottom 4 outputs here running various drums. So, and an envelope. Let me think about this. So let me trace through it. So this first one here, you can't really see this, but I'm just going to describe it to you anyway. But this first one here, right, is running kick drum. This next one is actually running the envelope to the filter, which has given us the filter. That bit. Then I got the next one down is running my snare, and the one after that is running the open hi-hat. Now, to run the hi-hat, I've actually taken the original pulse out, which is here, and that's running the hi-hat. So I've got the hi-hat going most of the time, and then when it's not playing, it gives the open hi-hat an opportunity to fire. And that's all controlled over here on this molten motion meter running as audio mixer. So I'm getting the motion meters in here nicely, I have to say. And it just jams. It jams. I mean, in some ways the drums are that little bit too random to have all the time, but it's the sort of thing you could easily mix in or drop to or use for a bit or modulate in another way, or have something underneath which is keeping that first beat always going or that off beat always going. That is super nice. Okay, one last thing which has been driving me nuts, right, is the difference between the gates output and the pulses output on the back of the Turing Machine. Now it's on gates at the moment, and the reason for that is that the gates means that on every time it gets a tick, it opens and then shuts. So you've got this steady movement, open and shut, whereas when it's on pulses, when it's on a trigger, it just fires and then it's back again. So when I get my two notes, you know, a bass note and a top note through here, it would be different. Let me show you that. So if I take this out of here and then plug it into pulses, the mix now of outputs from these here through my motion meter is now mostly at the bass line and then triggering up like that, as opposed to stepping up, stepping down, stepping up, stepping down. So that's kind of the difference. But there's something more than that going on. If I take that out of there for the minute. Now the pulses output is actually can be controlled, rather the width of that output can be controlled by the width of the clock going in. So the clock going in, I've got coming from Pam's over here, the width of the clock that's coming out of Pam's that's going into it, I can dial that in and that'll change how long things are held on for, which we can't hear at all. Let me work out how to make that hearable. Okay, heck, to try to demonstrate this, I'm going to use it just into a VCA just to turn the sound up and down, right? So as I've increased the width all the way, you get a longer note. As I take that down, you get a much shorter gate. So potentially you can use the pulse width of the clock going in to alter the pulse of all those outputs. Probably need an envelope with sustain in order to appreciate that a little bit more. So ultimately, I think what we're saying is that you should have the BitBuddy on the gates. And then, if you've got a pulses, you can use that on the pulses output. So while that melody's going on over there, I can stick another one into something else. And so now, remarkably, I have two tunes and a rhythm section being run purely by the Turing Machine, with its BitBuddy and a little bit of pulses. So there you go. Make of that what you will. That is the BitBuddy. an easy build, some tricky surface mount stuff that isn't really tricky. It just takes a little bit of patience and a little bit of tweezer action to get ready. It plugs beautifully into the Turing machine, gives you all of this weirdness that's going to melt your brain for a little while, and then you'll just go, oh yeah, right, okay, so it does the thing with the thing. It's brilliantly creating rhythms, it's creating notes if I mix it and allow it to, and it can run all sorts of things. Far more than I thought it was. I thought it was going to be a bit of a throwaway thing. Thought like, oh yeah, you know, it generates a couple of triggers and that. Which of course it does beautifully simply, but it can also start doing a lot more, and it's got me really thinking, scratching my head and wondering not only how awesome it is to use within the system. It's also made me dig out my pulses, which I've ignored for a long time because I thought it just created a whole load of stuff that I didn't really need. Whereas now I'm thinking about it completely differently. That is the difference in my modular maturity from all those years ago when I made the Turing machine and the pulses to go with it. And now I feel perhaps I've evolved a little bit, which is interesting. It's still, you know, there's something about the sound, there's something about the melody from a Turing machine which is quite interesting and quite unique to some degree. And sometimes it's not really always suitable and everywhere. So what I've seeming to be learning, what I seem to be grasping, is that if you can manipulate it just a little bit more, then it really starts to come together. Don't get me wrong, it's beautiful by itself. But through, for instance, I mix it up with an arpeggiator coming from here just to shift it around. So it's not just kind of the same thing running around. It then shifts to another thing running around. And that's really interesting. Using this mix through the molten motion meter here, it's really interesting. Not thought about that before. It took me a little bit of time to grasp what the heck was going on there. But another fascinating way to generate a melody. As for the drums, it's great. It's like a really good break in somewhere, and then perhaps there's a way of dropping back to something more straightforward, and then coming to this later on. As I'm thinking in live performance wise, which just gives it this really random jazzy sort of flavour before then finding your way back to something else. So this has been a massive learning journey for me, completely unintentionally. But that's great. That's what you need. That's what we need. We always need to be challenged and shown that there's another way of thinking about things. And that's what this did, I think. But otherwise, what a lovely easy build. That was nice. Shame about the thing, me having to resolder everything, thinking I'd done something wrong. That's the only slight sour note in this whole thing, is that I genuinely believed that I had messed up because there were no lights on it. But remember, folks, you have to plug something into it first, because that's where it gets its earth from, because it's not using the entire width of the pulses on the back to do the thing. I don't know. It's for silly reasons, but hey, that's what we have, and you're going to be plugging it in, so that's all fine. Great. So there you go. I hope that was helpful. And in the meantime, go and make some tunes.